Alright, welcome to this next video. We're going to be sort of ramping it up in this next one and talking about when we've got equations where the variable happens to be on both sides, okay? So your learning goal for this one is that students solve linear equations, so not a super difficult one necessarily. And by the end of this one, you'll want to be able to solve linear equations where the variables are appearing on both sides of the equation, okay? Right, probably the first thing I want to talk about is what does it actually mean when we've got variables on both sides of the equation. And so here we've got an xy Cartesian plane for ourselves. And let's say that this equation here might be x plus 3, and this equation on the blue one is probably going to be, actually better remind you, this is y equals, okay? So that's why these are called linear equations, okay? Is because when you plot them out with the set of x coordinates, the y coordinates you give back sort of ends up going nicely on a line, okay? And we'd call this other one here y is equal to negative 2x plus, let's say 4, okay? And what we're saying is that when we've got variables on both sides, it's saying that these two equations need to be equal to each other, so that there is one x value here, whatever the x value is here, yeah, this one. That's the solution for both of them when they're there plotted at the same time. And so you would write negative 2x plus 4 is equal to x plus 3, okay? And maybe you can quickly figure that out, that's going to be negative, it's going to be 1, okay? So we're going to see now how to quickly solve those kinds of ones, and ramping up into including when brackets are involved as well, okay? Right, so when you've got an equation with variables on both sides of the equation, you deal with it by collecting the variables onto just only one side, okay, because that allows you to deal with it. Now, it doesn't really matter which side we go for, and I'll show you some of the instances where if you do make a particular choice, there's sort of ways around it if you feel like you might have done the wrong thing, even though there's not really a wrong thing to do, as long as you're sort of carrying out the things that you're allowed to do from an algebraic perspective, okay? Doesn't matter how you get there, you'll eventually get there. Okay, so let's have a look at some worked examples. So we've got 7c plus 2 is equal to 6c plus 5, all right? Now, what you want to do is get all your variables on the one side, and it's usually easiest to get them onto the side where there is the most of that variable anyway. Okay, so there is 7c on the left-hand side and only 6c on the right-hand side. So the first thing we've got to do is we're going to get rid of this 6c, okay? Get rid of it, okay? And the way we do that is because it's a plus 6c, it's a positive 6c, we're going to do the opposite of that, which is to subtract 6c, so not x, 6c from both sides. Keep on writing x, probably because it's what I usually use. So minus 6c from both sides, and I'm going to write a little bit longer version of what this looks like. So you'll have 7c minus 6c plus 2 equals negative 5, okay, because the 6c is gone. Okay, now let's simplify this. 7c minus 6c is just 1 plus 2, so 1c plus 2 is equal to negative 5. All right, now we have our simple linear equation that we can deal with. There's my variable, there's the next thing that's operating on it, so we're going to undo that by subtracting 2 from both sides, and I'm going to be left with c is equal to negative 7. Okay, done. All right. That's one there. Okay, let's scroll down to our next one. Okay, this one here is going to be an interesting one. Okay, so I'm going to show it solving both methods so that you can see that no matter which way you take, it's going to sort itself out in the end. Okay, all right. So on first appearances, it looks like there's 5x on this side, but it's negative 5x. It's easier kind of to have more positive amount, okay? So this is the one here that we're going to get rid of, okay? This one's got to go, and so that everything's going to be on the right-hand side. So the opposite of that is going to be plus 5x to both sides. Okay, so I'm left with 14 is equal to 5 minus 2x plus 5x. If we simplify that, we're going to have 5 minus negative 2 plus 5 is 3x. Okay, now we're just left with the normal linear equation that we deal with as normal. So I'm going to subtract 5 from both sides and be left with 9 is equal to 3x. And then divide by 3. And we are left with 3 is equal to x. Okay, it doesn't matter that the x is on the right hand side when it usually kind of ends up on the left hand side. Doesn't really matter. Okay, let me show you what happens if you choose to go the other way with your initial simplification. Okay, so our equation was, I can't remember, 14 minus 5x. 14 minus 5x is equal to, I'm going to say 5 minus 3x, 5 minus 2x. Okay, 5 minus 2x. Okay, what if instead of saying let's go with the 5x being removed, let's try and get rid of our 2x, our negative 2x. So that means we're going to add 2x to both sides. Plus 2x. And so that leaves us with 14 minus 5x plus 2x equals 5. Okay, so let's simplify. We have 14 negative 5 plus 2 is equal to negative 3x, and that's equal to 5. Alright, so now we're going to go about our working here. So as our x, the next thing operating is the negative 3. Be careful with that. And then now 14. Okay, so the first thing we're going to do is get rid of this 14. So that's going to be, it's adding. So that means we're going to subtract 14 from both sides. And I'm left with negative 3x is equal to negative 9. Okay. Then, because the next thing that's operating on the x is the negative 3, I'm going to divide both sides by negative 3. Divide by negative 3. And I'm left with x is equal to, so I've got negative 9 over negative 3. And you remember the negative divided by negative is a positive, which is x is equal to 3. Okay, so you see, it doesn't really matter. As long as you follow the operations correctly and you do things that you're allowed to do in algebra, you'll have no problems at all. Okay, all right. Last little example for us here, and this is where there's variables on both sides if there are brackets involved. Okay, the way that I super suggest that you go about this, since especially 7 and 3 are they're prime to each other, so we can't really do any cancelling out there. So the number one thing you're going to have to do is you're going to have to distribute the expand your brackets first. Okay. So 7x plus 7 times 4 is 28 is equal to 3x minus 12. Okay, once we're here, then we can go, all right, there's more on x on this side, so this is the one we want to try and get rid of. So let's take 3x, and we're left with 4x plus 28 is equal to negative 12. And once we're finished here, it's the plus 28 that's happening to both sides. So I'm going to subtract 28 from both sides here. Take 28. Take 28. And I'm left with 4x is equal to negative 40. Okay, and then the last thing that's happening is that 4 is multiplying to both sides. So I'm going to divide by 4, and I'm left with x being equal to negative 10. Okay, and then we're done. So for that one there, that can get a little bit long and arduous because of the brackets on both sides, but it's sort of the same as the other ones where if you just follow the correct processes through, you'll have no problems at all. Okay, so thank you so much for watching. That's about as advanced as your equations are going to get at this level in grade 8, and I really hope you enjoyed that video, and remember, practice, practice, practice is going to make it sure that this stuff just becomes so easy for you, and look forward to seeing you at school. Thanks.